Okay guys, so here we are back for the second part of this video. So let's go ahead and do some review. This is what we learned in our last lesson, right? If you have a derivative that goes from positive to negative, that is a local maximum. If you have a derivative that goes from negative to positive, that is a local minimum. If your derivative does not change sign, it has neither a min nor a max. So this is what we did. This was called the first derivative test, right? We look at the sign change to determine the sign change of f prime to determine relative mins and maxes. So this was corresponding to drawing a sine line graph of f prime. So if you had a graph that went like positive, positive, negative, positive, like here you had neither, where because it just went positive, positive, positive to negative was a max, and then negative to positive there was a min. Okay, so this is great, but sometimes you can't actually find a sign change of f prime. Like maybe the equation's too difficult to draw a sine line graph of. But one thing great is that you can use what's called the second derivative test. The second derivative test says this: as long as f prime is 0, you can determine whether it's concave up or down to tell us if you have a max or min. So think of an example, right? If you have something that looks like that, right? We see 2 points where we have a slope of 0. That point where we have a minimum, at that point we're concave up. At this point where we have a maximum, we're concave down. So this is a useful tool. So if you have a first derivative is 0, and that's crucial, like for all of these, you need your f prime to equal 0. You need to have a critical point. If your first derivative is 0 and you're concave up, that's the situation where you have a local minimum. You're concave up. The second case is if your first derivative is 0 and the second derivative is negative, that means you are concave down. That means you have a local maximum. And again, we can see that over in the picture there. So, if the second derivative is 0, this doesn't help. You may or may not have something. And in that case, you need to use the first derivative test. So if the second derivative is positive or negative, you can conclusively state whether you have a max or min as long as that first derivative is 0. Okay, so I'm going to show you how this is useful. So here's a problem. Like you could do a sine line graph of this, right? Your first derivative is 6x squared minus 30x minus 36. So if you factor this out, you have 6 times x minus 6 times x plus 1. So you have x equals 6 and negative 1. So those are your critical points. But if you take a second derivative, f double prime here is 12x minus 30. So if you want to look, for example, at x equals 6, your first derivative equals 0. Your second derivative is 6 equals 72 minus 30 is 42. The actual value doesn't matter. What matters is that the second derivative is positive. So that's saying you're concave up, you have a slope of 0, so it is a local minimum. I don't have these memorized. I just kind of draw the pictures like that just to remind myself. And same thing, if you look at x equals negative 1, your f prime equals 0. Your f double prime and negative 1 is a negative number, so that corresponds to it being a local maximum. Okay, so that's just a useful tip. We're not going to use this a ton, but it's good to know. And I pointed out down here, like if the second derivative is equal to 0, you can't tell. You have to use the first derivative test. So you can always use the first derivative test if you can make a sine line graph. So you can always use if you can make a sine line. If there's something that's preventing you from making a sine line graph or seeing the signs in some other way, then the second derivative test can be useful. And we'll see that throughout the year. Okay, so just remember that's an alternate way to determine mins and maxes. Here's the next thing I want to talk about. Here's an example where you have an f prime graph, and this is going to ask questions about f. So this is a type of problem they love to put on the AP test. I can guarantee they'll put it on the AP test this year. And they're going to ask you, where is the function increase, decreasing, mins, maxes, concavity, points of inflection, based on a graph of f prime. So again, this is f prime. This is a graph of the slope of f, not a graph of f. So the key tip that I want to give you guys is to use the definitions. And I'm going to write these up exactly like I would on the real AP test. So where is it increasing and decreasing? Well, this function is increasing when my first derivative is positive. So this is a graph. My y value here is the first derivative. So when we're above the graph, that means my first derivative is positive. If we're below the graph, that means my first derivative is negative. So let's see. We're increasing when my first derivative is positive. So that happens here from -6 to -2. So that's -6 to -2. And we're also above the graph, it looks like from 2 all the way up to 5. Okay. So that sounds good. As for where we're decreasing, we are decreasing when that first derivative is less than 0. My first derivative is less than 0 anytime I'm below the axis here. So that happens on the interval from -2 to 2. Again, we use closed brackets for increasing, decreasing. Okay, so for local mins and maxes, we want to check for sign changes. So local mins and maxes, we're going to look, where does that first derivative change sign? So change sign of that first derivative. And I see 2 times. It goes from positive to negative. Right, my first derivative is above the graph and then below the graph. And that happens at -2 and then also at 2 the other way. So at x equals -2, my f prime goes from a positive to a negative. So my derivative is positive and negative, so it is a local max. And one thing I want to stress, when I'm writing this out, I'm not just saying it goes positive and negative. I'm not saying the graph goes positive and negative. I'm saying f prime goes positive and negative. I'm being very clear about which function it is, and that's what they're going to be looking for in the AP test as well. At x equals +2, my derivative is below the graph and then above the graph. So my f prime goes from a negative to a positive. So that means it would be a local minimum. Okay, so now we're going to ask in this question about concavity and points of inflection. So the tip I want to give you is this. We're talking about the second derivative now. F double prime is the slope of my f prime graph. So we're talking about where does the slope of this f prime graph have a positive sign versus a negative sign. So part C asks about concavity. So it is concave up when your f double prime is positive. And f double prime, again, of course, is the slope of f prime. So make sure you write this out. You're showing that, or write f double prime is derivative of f prime, whatever. So where do we have a positive slope? So looking at our graph, we have a negative slope, negative slope. Okay, I see a positive slope here. So that happens, it looks like from 0 up to 3, we have a positive slope that whole time. Okay, so that happens here on the interval from 0 to 3. Okay, what about concave down? Well, let's switch colors here. So we're concave down kind of in here, and then we're concave down here because the slope of f prime is negative. So that looks like from 3 to 5, and then from -6 to 0. Okay. So 3 to 5, and -6 to 0. And again, I'm going to write that out. Concave down on there, and that happens when my f double prime is negative. That's when my f prime has a negative slope. And again, be very clear when you're writing these up. So let's go to part D. D of this problem asks about a point of inflection. Okay, a point of inflection. A point of inflection is when the sign of f double prime changes. So that happens when the slope of f prime changes from positive to negative. Okay, and I kind of trying to highlight this up above, or I guess I should be clear, or negative to positive. So we start on our f prime graph with a negative slope. So when we're going down, that means my f double prime is negative. My f prime has a negative slope. But then we switch to a positive slope right there. My function, my f prime function has a positive slope on that interval where my f double prime is positive. So the 2 points where we change the highlighting kind of here and here, those are my inflection points because that's where the slope of my f prime graph is changing from negative to positive and then positive to negative. So kind of where do we switch from concave up to concave down? That happens at x equals 0 and then I think 3. Okay, and again, that's where my f double prime changes sign, also known as that's when my f changes concavity. Okay, so practice writing your solutions up clearly like this, bring questions to class, and I'll see you guys soon. Thanks for watching.